This episode of Hoochos is brought to you by SpiderFarmer. Welcome back to Hoochos. Today on Hoochos, we'll be 3D printing, setting up, and time-lapsing the latest 3D printable design that I've got available on my Patreon, the flood and drain technique, and the SpiderFarmer SE3000 full spectrum grow light. Now before we start, there will be timestamps in the description so that you can skip ahead or replay parts that you want to replay in the future. Let's get to 3D printing the model. This is the 3D printable flood and drain hydroponic system. So all of this will actually print without supports. I've designed it that way. There are multiple parts to the print. You have the lid, the flood and drain box itself. On the bottom, you've got the two holes where our flood and drain fittings will fit. This is the entry pipe, and that is a 13mm barb on the bottom for each of these fittings. This is the exit pipe, and this is where the flood will actually drain back down into the res when the pump is on, and this is where it will drain when the pump is off. But this is where it fills from as well. This exit pipe I've made two versions of. There is a shorter version and a longer version, dependent on how high you want the flood in your grow bed. The drain pipe has a 19mm barb. This allows you to run a pipe back to a res you have away from underneath the grow bed. As with a lot of the files on my Patreon for different hydroponic systems, we are going to have to use Mesh Tools, which is a free download. You get that from the Cura App Store, and we're going to split the model into parts. This just allows me to have all of the files, all the STLs in one file, so that it's less likely that people will lose individual parts to the STL kits. That allows us to drag and drop these onto our build plate. So this will allow us to print our shroud in one print. So this will print at 100% infill density, and it's going to take 11 hours and 28 minutes to print. Now it says 248 grams of filament. However, in the real world, it is going to take 179 grams of filament. And actually, while we're here, let's just do an all up. 250 grams for all of the pieces. Now, that means you can print 4 per 1 kilogram of filament. If you're getting your filament for $20 a kilogram, that means this whole set is only going to cost you $5 to print. 11 hours, 28 minutes for that part of the set. And for our flood fittings, and we need to multiply the nut because there's only one nut on the models. We multiply the nut by 1, and we have a second nut. So we can then arrange all models again, and we end up with 5 hours and 23 minutes. So 100% infill density, no supports whatsoever because that's the way I've designed it. I recommend using PETG. That's the filament that I've used on all of my 3D prints, and a 0.8mm nozzle. All right, let's get to building the system. Okay, so some of the things we'll be needing today. You'll need your flood and drain kit, obviously. I've got a silicone sealant here. You'll need a tape measure and a pen to mark out where you're going to drill. And we'll also be using, as an alternative to the silicone, these are silicone seating washers for toilets. These are for the internals of a cistern, and they come in a 2-pack. One is slightly larger than the other, but I think we can work with 1 2-pack for both of our fittings for each of our flood and drains. You'll also need something to flood. So this is a cheap kiddie pool, and it is perfect for a grow room, because my grow room is 1 meter by 1 meter, and this kiddie pool is 90 by 90. Now, I will be making some adjustments to this pool that you do not have to make. I'm going to be cutting the sides down so that it's only half of the height. The reason being, I'll only be flooding and draining about that far, and I do not need the whole height of this pool. So I'm going to be removing the outsides so I have a smaller footprint within my tent. I'm just going to mark around the outside of my container, and then I can cut around it with a multi-tool. Okay, so now all there is to do is to cut holes in the bottom of this grow bed where we want to place the flood and drain shroud and fitting set. And I'm just going to trace that directly onto the bottom. So this hole saw size is 1 inch and 1/3 of an inch, but it's 35 millimeters for those of us anywhere in the same region. Sorry, Americans. So I'm just going to drill out these holes, forward for the central hole, and then reverse, like that. I'm trying to make them as clean as possible though, because I want them to seal. Beautiful. All right, let's see if they fit. Turn it over. So again, the way that I've designed these parts is so that this sits straight into the bed, and then these parts fit directly over the top, and they should seal. I can put this one on there as well, and we just screw from the bottom, and that should hold it in place. But before I do that, I want to add in our seals. So these are our silicone seals, and I want to just put them at the bottom like that, and that gives us a nice seal around the bottom of these flood and drain outlets. And I'm just going to do up the nut like so. And that is our flood and drain setup. How good. So one other thing I'm going to be playing with in the future for these flood and drain systems is the idea of printing TPU as a seal. So watch this space, because I'm not happy with the seals costing as much as they do, because it just takes away from the bottom line if you are trying to be thrifty in making your own flood and drain systems. I do think that the shroud alone is worth printing and making this system, because anyone who has ever grown anything in flood and drain knows roots get into all the pipes, and you just need a way of cleaning it without pulling back all that media. So now that our flood and drain bed is built, let's take it into our tent, set it up, and test whether it's watertight and whether it really needs to be watertight. Okay, so here we have our grow tent and our SpiderFarmer light fixture, the SE3000, which we'll be putting over this grow. Now this is how I would normally set up a grow bed like this. You have your proprietary fittings, which disconnect in the same way that I've designed. They have seals on them, but the media just gets all around the outlets and inlets. That is where our new design comes in, where we have our shroud to protect it. And it's a lot cheaper. I think it's about $5 worth of printing material. To set this up, this is a cheap 1 meter blow mold table. It allows me to keep the grow bed up off the ground above the res. I've cut the table's legs so it's on a slight slant back towards the inlet and outlet. Not a lot, just like 1 or 2%. I've cut the legs also so that it's the perfect height above my res. We'll add on top of this a flood and drain grow bed. like so. Below this, I'm going to add in one of these cheap rubberized plastic buckets. Now, these are great because they have gallons and liters marked on the side, so you can tell how much you've filled up and how much nutrient, pH adjuster, etc. you need to add in. It's also round and rubberized too, so there's no problem with this actually bowing in any direction because the water will be pushing out equally on all sides, so it holds its own weight rather than the square plastic buckets which can bow out on the sides and might fail on you. So we put that underneath, and then to that we can add in our pump and our section of tubing, which is just garden hose. The pump I'm using is the AP550. The reason I'm using this is because it only really needs to rise a meter, and the head on this is 1 meter. So it's perfect for this application. It's cheap, I think it's about 20 bucks, and you can get away with using it. So connect up our pump. So that just pushes over the top of our inlet pipe. Now, the beauty of the table sloping back and the flood and drain being right above the res is we don't really need to worry about any leaks. This is going to be set on a timer and only flood infrequently as well as for a short period of time, but we'll cover that at the end. Even if it does leak, it will only be leaking for a short period because the entire bed should drain anyway. So it's full to 35 litres. So I'm just going to stop it there, and now I'm going to plug in the pump and we can see if it works. Turn on the light and I'll turn on the pump. There we go. Look at that. How good. So we can see that the bed's filling up. That's great. We do have a tiny leak down here. Let's see if I can get it on camera for you. Yep, so it's coming out of the return pipe, but that's fine because it drops straight into our res. So there's no problem there. So the problem here would be if you didn't have your res directly underneath the bed. But I feel like you could actually seal that. So that is actually what was leaking. Now the way around this would be to just put a bit of silicone around that if you wanted to permanently raise the level. But if you want the level higher, you can just add that in and that will bring the level up. So as you can see, the bed is fully flooding. It is shallower at this end, and you can tell because these edges here are filling up, whereas these ones aren't. I wanted that because I want it to drain back down so that there's no excess nutrient left in between floods, because we want it to drain completely each flood. So, as you can see, the inlet's working and the outlet is draining, and it's giving you a ton of room to clear out roots. So this is working, this is actually working really well. I'm really happy with this. All right, so let's have a look underneath. So you can see it's draining completely through the return pipe. It is leaking a little bit through both seals. So if you do want that to be sealed and have your res somewhere else, you will need to seal those with silicone. But in this scenario, I'm completely happy with that. Obviously the bed isn't going to fill with this much water every time it fills because the grow media will take up a majority of this space. But this is just giving you an idea of how the system works. I'm now going to turn the pump off and we'll have a look at how it drains. The pump is now off, and what happens here is the water stops returning through the return pipe and it now starts draining back down through all of the holes in the side of this, through the pump, and it then returns to the res below. So what you'll start to see is this one will stop returning because it's actually returning through this pipe and down through the pump. And then that is your off cycle. And this whole bed should drain. And you can see it draining. So it's now time to add in our media. I'm using Hydroponic clay balls. They wash off best in a basket like this. I got this from a tip shop and I was stoked to find a Bunnings one. I wash them off and then I just add them in. You can use whatever media you like, scoria, hydrogen, riverstone, whatever's cheapest for you. Just make sure it's pH neutral and you'll have a good time. I'm going to fill it up, hopefully to the top of the flood and drain box. And as you can see, look at that. Have you ever had full access to your flood and drain pipes whilst your bed was full? I dare say you haven't. I'm now going to set up my nutrient solution. So this is 40 litres of water. I'm going to pre-balance my water with 4 mils of pH up. This is going to be different for every person because their water is going to be different, and you'll know by adding your nutrient into virgin water and then seeing how much you need to raise or lower it by, and then note that down, and next time you can raise it or lower it before you put the nutrient in, and you won't suffer any precipitation. In the meantime, it's probably fine to get a little bit of precipitation by adding it afterwards. It's just that you can prepare yourself for the next time you add it, because it's not likely that your pH of your water will change unless you change water source. It can drift over time because of varying acidity of rain if you've got tanks, or varying acidity in your town water, but generally you're pretty set with your pH shifting. So I'm now going to add in my nutrient solution. I'm going to add in a grow nutrient solution for the first part, and then I'll switch to a flower once our plants turn to flower. So I'll put that in and we can test our pH and our EC. 6.4 on our pH, which will be about perfect. This is the EC, 2.3. So that's pretty much perfect too. So these awesome little plants are called dwarf tomatoes, and they are perfect for grow room growing because, as the name implies, they're dwarfs. So they won't get excessively large and overtake your grow room. And I can plant 4 of them in this space without worrying. And these ones have black tomatoes or purple striped tomatoes, I'm pretty sure. I lost the tag for them, but that's usual. They don't get much bigger. They'll only take up about that much space. We're all set up. Cameras are rolling. Plants are in. I've just set the first flood. Here we go. Right at this point that you can see the start of all my problems. That is the point where I must have turned the light on just to have a look at the plants and forgot to turn the timer back to an on-off cycle. This, combined with the light, which is actually extremely strong, and I underestimated how strong it was, caused the plants to shrivel in the way they are. You can see there's a heap of roots getting in, and I have added in an exhaust fan because some of the problems you see here are a combination of over humidity as well as over intensity of light for too long of a period. So I decided to start again. I ripped out the plants. You can see that the roots are extremely healthy. So the flood and drain technique is working fantastically. It's just the environmental conditions that I need to get right. And I didn't at this point realize that the problem was stemming from the timer being turned off as well as all those other factors. So I never actually rectified that problem. I ended up just installing some mesh for these African horned cucumbers to climb up, and I planted some African horned cucumbers. With most of our problems solved, we can replant our plants, restart the time lapse, and see if we can get a better result the second time around. And will you look at that result? Let me just get the light out of the way. By this point in time, I've realized that the light has been on 24/7. I do not pretend to be a professional grower, and I'm still learning the ropes when it comes to indoor growing, and I will be for some time to come, but hopefully we can learn together. As you can see with this cucumber vine, we have a massive hot spot in the center where the leaves are burnt, and that is because I've been running this light. I was actually only running it at 80%, and I thought that that would be absolutely fine. But because it was on 24/7, that was not absolutely fine. The SpiderFarmer SE3000 has actually been a really good light. It's way more powerful than I expected. Properly managed, this light would be absolutely fantastic. The flood and drain system has worked flawlessly. In fact, let's have a look at some of the roots that these cucumbers are putting out in the system. I'm actually going to just sacrifice these plants. We can have a look at the roots that they've formed. You can actually see the roots traveling through the clay balls on the surface here. I'll pull them back, and those are the roots coming off the cucumber plants. That's incredible. And they're just traveling throughout the clay balls in the system. Sorry, buddy. You can actually make out where the roots have made their way around the exterior of the grow bed. How cool is that? And had this been closer to our plants, this would have been really useful, because this massive roots would have started to get down into our flood pipe and block this up. So given a bit longer, this will definitely come in handy. So the flood cycle that I have this flood and drain bed on is a 12-3-6-9-12 flood cycle. So it floods once every 3 hours, and it floods for 2 minutes. I'll put a screenshot of the app up there, and I use a smart timer. Now, the reason it floods for 2 minutes is it takes 2 minutes for the grow bed to fill and start to drain back into the res. This is the way that I've set up this bed. I don't want it to flood any more than it needs to. So the moment it starts to drain into the res, we can stop the flood, and our grow bed is refilled with nutrients. All of the pores in our hydroton and all of the roots are wet, and then 3 hours later we'll flood it again for another 2 minutes. I would leave the flood cycle at the length of time it takes to flood your bed and then start to drain. So just time it, and then that can be your irrigation cycle. And the time in between is a nuanced variable that you'll have to figure out for your particular situation. Adapt this to how hungry the plants are, how thirsty they are, and so on and so forth, plant type, etc. I'm actually really stoked with how this 3D printable flood and drain system has performed, and I haven't had a problem. There's been no spillages or leaks that I didn't already know about, so they drain back into the res when it does leak. And if you wanted to run a res away from underneath the system, all you would have to do is seal these parts with silicone, because that is where the leaks are coming from. They're actually leaking back down through the pipe anyway, so you may not need to seal those parts. You may just have to put a 19mm pipe, which is what this drain is designed for, running back to your res. All of the STL files for this system are available on my Patreon. The light is linked in the description. Thank you to SpiderFarmer for sponsoring this episode. Happy hydroponicking, and I'll see you next time on Hoochos.